Okay, so continuing with the idea of parallel lines, but now we're going to look at it from the other side of given information about angles, can we prove that lines are parallel? So our essential question is just that. How can you prove that two lines are parallel? So first, let's start with a couple definitions. So converse is formed by swapping statements in an if-then statement. So some very basic ones. Fully admit that not just males play football, but for the sake of keeping it simple and not wordy, we have if you are male, then you play football. If you play football, then you are male. So the converse would be that second statement, because what has happened is we switched our if became our then, and then our then became our if. So let's take a look at one specific to parallel lines. So we have statements, lines L and M are parallel, angle 6 and 3 are supplementary, angle 4 is congruent to angle 6, angle 3 is congruent to angle 7. So use two of the given statements together to complete a statement about the diagram using the same side interior postulate. So if blank, then angle 6 and 3 are supplementary. So if lines L and M are parallel, then angle 6 and 3 are supplementary. Now write the converse of that. So we're just going to flip that. So if angle 6 and angle 3 are supplementary, then lines L and M are parallel. So now we know if we can show we have same side interior angles, then we can prove that we have parallel lines. All right, another one, but now we're going to do alternate interior angles. So if blank, then angle 4 is congruent to angle 6. So if L and M are parallel, then angle 4 and angle 6 are congruent. So the converse of that be angle 4 is congruent to angle 6, then lines L and M are parallel. So now we've shown that if we have alternate interior angles that are congruent, we now give the lines, or force the lines to be parallel. And last one here, if L and M are parallel, then angle 3 and 7 are congruent. So angle 3 and 7. So then the converse of that is if angle 3 is congruent to angle 7, then L and M are parallel. So same idea, if we can prove that two angles that are in the position of corresponding are congruent, then that forces those lines to be parallel. So how do you form the converse of a statement? Go ahead and write your answer down this and be ready to respond and share that back when we come into class. So here's some converse of what we had shown in 14.2. So converse of the same side interior, converse of alternate interior, and converse of corresponding. So now we're stating the angles are congruent or supplementary, that then forces those lines to be parallel. So example of a problem, how this can be used. A mosaic designer is using a quadrilateral shaped colored tiles to make an ornamental design. Each tile is congruent to the one shown here. Look at the situation, use values marked angles to show that the two lines are parallel. So measure of angle 1, as we look at it, angle 1 is the bottom right, so that'd be the bottom right of that, so that is 120. And the measure of angle 2 is the bottom right, which is 120 again. So then the relationship between those two would be corresponding angles. Which then tells us that L1 is parallel to L2. All right, your turn. So go ahead and try this one out, and we'll discuss this one in class. All right, so the parallel postulate states that through a point P, not on line L, there's exactly one line parallel to L. So as a quick introduction to this, we'll do some constructions more next week, but I want to show you what a construction may look like here. All right, so based on that construction, why don't you explain how you know that the line produced through the given point is parallel to the given line? Think back to our converse statements that we've already discussed. All right, so a little freebie on here. This isn't in your notes, but I want you to think about these two questions. What are some congruent angle pairs that can be used to prove two lines are parallel? And what are some angle pairs that must be supplementary to prove lines are parallel? So think back to all the different angle relationships we've used. Be ready to share these out in class. A little practice here. So as we look at it, identify the type of angle pair and how do you know that the line L and M are parallel? So if we look at angle 3 and 5, those are relationship as alternate interior. And since they are congruent, we then know that L is parallel to M. And then if we look at 4 and 8, that one's 35 and that one's 35, which means they have the same measure, which is the same as saying that angle 4 is congruent to angle 8. Those are corresponding angles, which then would tell us that angle L is parallel to angle M. All right, these two I want you to work on your own. So these are some added ones that also aren't in your notes there, but you can add them under 4 and 5 there and figure those out. We'll discuss them in class. Now suppose two lines are cut by a transversal such that the alternate interior angles, so angle 1 and angle 2, are both congruent and supplementary. What would you know about those angles and lines? Then last, our essential question, check in, name 2 ways to test if a pair of lines should be R parallel using interior angle formed by a transversal crossing the two lines. So go ahead and come up with your answer and be ready to share that in class. And last, your assignment for 14.3.